Question number 5. Use the function p of t equals 2 times 3 to the t minus 1 to answer the question below. So the graph of the function is shown. Which values best describe the range of the function? And a little reminder about range over here on our bottom right. Bring up my pointer here for a second. So the range is all the values that the y's can take. So here's my y-axis. Okay, we've labeled it p of t because that's the name of my function, but those are just the values of my y's. In an exponential function, remember that these are going to be all the values that are greater or less than the asymptote. So if I take a look at my function, here's my function, I notice here that as my x values are decreasing, that my function is approaching this line right here. So if I were to draw that line in, kind of take a highlighter here, it looks like, and I apologize about not being a very straight line, but it's like this line right here, which when we look at that line, it is going through right here at t equals, actually that would be y equals, so p of t, or y equals -1. Okay, so that's my asymptote. That's that -1 from my function. Okay, so my range, the values that my y values can take is going to be, if I look at this graph, it's anything above that line. Okay, if you look at all of my y values, all of my y's are above that asymptote of y equals -1. So if I look at my answer choices, any real number, well, nope, because it can't be anything less than -1. All real numbers greater than 0, nope. All real numbers greater than -1, there we go. So whatever your asymptote is, you have to look. If your graph is above that asymptote, it would be everything greater than. If your graph happened to be below that, then we could say it would be all real numbers less than. And it's never going to be equal to your asymptote. So just know that that's never going to be an answer choice because your line is just always approaching. It's getting closer and closer to the asymptote, but it will never actually touch or cross it.